So on I squared, the summation of I squared, I'm going to give you an example. So let's say I'm looking at the first 10 terms and I were to start to write them out. So of course, if I plug in 1, keep in mind that I would be plugging in this number first. So I'd plug in 1 first and I'd get 1. And then I'd plug in 2 and I'd get 4. And then I'd plug in 3 and I'd get 9. And then I'd plug in 4 and I'd get 16. And I'd keep going, and hopefully, let's see, if I plug in 9 I'll get 81, and if I plug in 10 I'll get 100. And hopefully you're noticing that this is in fact a pattern. Of course, I could actually put this into my calculator in a list and have the calculator sum up those numbers. It would take me a little bit of time. Or the shortcut is to use the formula, which is whatever n is times the next number times 2n plus 1, and divide all of that by 6. So in this particular case, n is 10 times the next number, which would be 11, times 2n plus 1, which would be 21, and then divide by 6. And of course I do a little bit of reducing. 3 goes into these, that's 2 and 7, and then I could reduce again, so that quite possibly I could do this without a calculator. And so I'm going to have 1 on bottom, and on top I'd have 35 times 11. And if you think about that, it'll look like this when you do 35 times 11. So I get 385. That was doing 35 times 11, of course. Okay, so the next one, I cubed, the magic formula is n squared times n plus 1 squared. And then divide that all by 4. So an example for that one is, what if I look at the first 5 cubed numbers? And of course, if I were to write those out, again, I would plug in 1 first. And so 1 cubed would be 1. And then plug in 2. 2 cubed would be 8. And then 3 cubed. And then 4 cubed. And then 5 cubed. And of course, I could do that the old-fashioned way, just add it up. Or I use the shortcut, which is, so n squared would be 5 squared. And then the next number, so 5 plus 1 would be 6 squared, all over 4. And again, with a little bit of canceling out, I'll have 9 quarters, which is 225. So I get the same answer either way. And one last reminder to yourself, you must memorize these formulas, or you're going to get stumped and you won't be able to work the problems. So if I expand this one out, remember I'm first going to plug in 1, and then I'd plug in the next number, which would be 2, and then I'd plug in the next number, which would be 3, and 4, and 5, and I would stop at 6. So that one's pretty easy. So now notice on this one that I is actually starting at 0. So first I'd plug in 0, which would give me 1. And then I'd plug in 1, which would give me 2. And then I'd plug in 3, which would give me, then I'd plug in 2, which would give me 3. And then I'd plug in 4, which would give me 5. And then I'd plug in, okay, I am totally struggling here. Back it up. Then I would plug in 3, which would give me 4. I don't know if I said that. And then I'd plug in 4, which would give me 5. And then I'd plug in the last number, which would give me 6. So notice here, I'm starting by plugging in 3 first. So 3 squared would be 9. And then I'll plug in 4, which would be 16. And then I'll plug in 5, which would be 25. Then I'll plug in 6, which would be 36. And last, I would plug in 7, which would give me 49. Okay, so pay attention to this one because this one's a little tricky. They're trying to trick you. Notice that the variable that I'm substituting in for is k, not n. So that makes this 1 over n out in front really just a coefficient, so I could put it here in the front. So it would look like this. Again, I'm substituting for k because it says k equals 1. Okay, so now if I plug in 1 first, first of all, this 1 over n is going to stay out in front. And then when I plug in 1, I'll have 1 squared plus 1, but that's 2. And then if I plug in 2, I'll have 2 squared plus 1, but that's 5. And then if I plug in 3, I'll have 3 squared, which is 9, plus 1 is 10. And the pattern continues. And the last value that I'm going to plug in will be n squared. And since I have an indefinite value because I'm using n, it's going to look like an expression, not a number.